Hey everybody, this is Alex Merced from alexmercedcoder.com with another video about prototypes and classes. In this video, what I want to talk about is the difference between giving a class or constructor function a method within the constructor versus giving it a method within its prototype. Okay, so basically every constructor function has a prototype. Meaning it has this object that becomes a prototype of anything it constructs baked inside of it. At least the old school functions do. Okay, so if I do this, const ninja equals function, okay, and then we'll just pass in name as a parameter, and we'll just say this dot ninja, or no, this dot name equals name, and then we'll just say this dot say name equals a function. Well, actually, I want this kind of function because I want to use the this keyword. This dot name. Okay. Console log this dot name. So even though this looks like a function, since I'm using the old school function syntax, the S5 syntax, it actually doubles as a constructor function, which means I can use the new keyword, and then there's this prototype object attached to it, which is why I can use the this keyword, because it's in reference to its prototype. So I can do const shinobi equals a new ninja, and the name of the ninja will be shinobi. Okay, and then I can be like shinobi dot say name. Okay, cool. Now, if I do this, I run it. Oh, Shinobi is not defined. Shinbabi, my bad. Shinobi. Save. And see, it works. I created this new instance of Shinobi, and this ninja called Shinobi, and it said its name. Okay, so I can do that with a function, and that function has a prototype because it's a constructor function. So technically, I can do something like so. Basically, I could define another method this way: ninja dot prototype dot kick equals, and here I'll just use an arrow function because I'm not going to use this keyword. Console.log kick. Okay. In Shinobi, we'll still have access to this function because I'm adding it to the ninja's prototype. So shinobi dot kick save. So even though I never assigned kick to a shinobi, and it's not part of the constructor function, it still will work. See, kick. But what's the difference? What's the difference between me doing this versus me doing this? The difference is this is going to get defined for each instance. So that means Shinobi is going to have its own instance of the say name function, and this is not 100% true, and I'll elaborate in a moment. Okay, so that means the benefits of declaring it every single time is that in a situation where you're calling a lot of functions, it'll be like it'll get to it faster. Okay, it'll run a little bit faster, but it'll take up more memory because every ninja will have its own version of say name stored inside of it. Now when I do this, I'm not storing the function in the constructor, so we're not constructing say name every single time we make a ninja. Instead, we are saying all ninjas have this function. This prototype object that is the ninja will have this function inside of it. And my understanding is that V8 and the other JavaScript engines now optimize this, so I don't think you have to worry about this as much anymore. Um, in a sense that I think when it goes into the constructor, it will just kind of optimize depending on the situation. So that's cool. But we'll come back to another situation where that's still an issue. Now, again, nowadays you wouldn't do it this way. Okay, the difference is this would no longer you don't have to do it in this function syntax anymore. You could do this. Okay, it would be class. Okay, and then we would get rid of this, and then this would all be wrapped in a constructor. So first, let me just put together the constructor. Okay, so this is literally basically the same thing, just slightly different syntax. Properties go in the constructor. Functions get defined outside the constructor. Okay. Save. Where did we go wrong there? Unexpected token. Let me just think. This dot say name. Oh, I don't need to do this anymore. I can just do say name now. And I don't need to do any more of this anymore when I'm defining a method of the class. And that's how it would look like nowadays. And the way I think V8 will work is that if you define the method out here, okay, it'll just add it to the prototype. But if I were to add a function in here in the constructor, so like this dot punch equals console.log punch, then it's going to be again constructed per instance. Okay, so let's experiment with that. So let me do. So what I want to do here in the middle is console.log Shinobi, and then I'm going to use Shinobi dot punch. Invoke it. And again, it's a class. A class is just literally the constructor function. It's just syntactical sugar, meaning it's just a different way of writing the same thing as that previous function method that I did. And then so the prototype is still attached to that class. So I can still do this. I can still do ninja.prototype and assign new universal properties that way. Okay, and notice here, now punch is a property of Ninja. So that means that function only exists on that Ninja, and the next time I create another Ninja, it's going to add that punch again. So there's going to be a bunch of copies of punch. Okay, well again, V8 optimizes the name, so that's fine. You don't see name in the object because it's part of the prototype, and you don't see kick in there because that's part of the prototype. So it just depends what happens when you define your functions inside the constructor versus defining it here. Okay, so keep that in mind. Okay, before you had to define your methods using this dot kick in my previous example, and which is why it would be part of it. Okay, so that's kind of lesson number one. So if you are going to define methods and you don't want them to be repeated every time you create a new object, you're going to define them outside of the constructor, or you could do ninja.prototype.kick. And actually, you know, this could be really, well, let's think here. Yeah, if you want to upgrade Ninja's powers midway through, you could do something like that. You know, that's neat. And then all ninjas will have the same power. Okay, so let's see here. Where am I? Shinobi, that's the name. Shinobi.kick. Okay, so again, you can do that prototype thing. Now, another situation where you would end up making several copies if you were to use like factory functions, depending on how you do them. So if I were to create a function that says, let's call like const create Ninja, and that equals name, and then I were just to do this, return an object, and the object has name. Actually, I can just do that. Name this dot kick. Actually, I don't even have to do this dot kick. Kick, and I just copy over this kick function. Then I put a comma there, and then I do punch. Just copy over this punch function. There we go. Oh, this needs to be a colon. There we go. Okay, so that would do the same thing, but again, I'm creating a new object with new properties every time. And let's just see what the syntax error is. What does it say? Unexpected token. Punch. Console.log punch. We don't need this here. That's the problem. Cool. So if I were to change this into create Ninja Shinobi, I'm saying it's not a constructor function. I'm not using the keyword, so it's not setting a prototype. It's what it's doing is just running the function, which returns an object, and that object has those same properties, so it should work the same, except for say name. I need to add say name. Okay. So for that, I am going to need the older function syntax, so I can use this function name. I don't need that function. Console.log name, and that will be this dot name. Because I can still use, and though again, if you haven't seen my previous videos, the way this works, this always refers to the object that invokes the function, period. Oh, and I need a comma. Save. There we go. Okay, so now the same code should work, even though I'm using this create ninja function, except I don't have necessarily a prototype. This object doesn't have a prototype. It's just a fresh object with these properties. Okay, so you see, this object now has the 3 properties attached to it. And that's how every single version of this object would be. It would just basically be me recreating the same things over and over and over and over again. Which memory-wise, if you have enough properties on there, objects with huge amounts of properties could be taking up a lot of memory. Again, it runs a little bit faster when you run the functions, because the way prototypes work is that first it would have to go look at Shinobi, the object, and then when it sees the property isn't there, so when the property wasn't there here, so basically kick and say name weren't there, if I wanted to use those functions, it would then look here and then go look at the Ninja prototype. Okay. Now, what I could do instead, if I wanted to change this function and make it work the same way, I could just make it refer to that Ninja prototype and do something like this. Return, and say set prototype of, and I have to do object dot set prototype of, give me a new object and set it to the prototype of Ninja, which again, it's going to take a look at that constructor function, which is the Ninja class, and take a look at its prototype object that's attached to it. Where's the error? Let's see here. Name. Okay, this is extra. Save. Now, if we run that, it should just work the same, except now you won't have all those functions inside Shinobi. Say name is not a function. Let's think about that here. It should be type prototype of. This might be just a weird thing because it's a class. What if I do this? Ninja dot prototype. Would that give me the effect that I want? Because I think it's looking for a specific object, so I need to refer to the specific prototype object that's attached to it. No, I guess that way doesn't work exactly. I'd have to create a ninja. Okie dokie. Cool. So if I were to do this, const model ninja equals a new ninja. Or I could do this actually. I could set the prototype as new ninja name. Although this really provides me no benefits over just doing new over here. It's literally just an extra step. But I think that should fix it. Yep. The only benefit we see here is that now we see none of the properties inside Ninja. Okay, so now our Shinobi Ninja still works, except it doesn't have... Oh, because I put name in here. Oh, I want to put the variable name. That's why. Save. So literally it'll do the same thing, except none of the properties actually belong to the object we created. Okay? So that's a benefit. Like if you have certain functions you are going to assign... yeah. That's fine. Okay. But the thing is that you can also just assign, again, properties afterwards. So I could, if I wanted to, I could assign a method to Shinobi afterwards, but it would only exist on Shinobi. So I could do like Shinobi dot fight equals console dot log fight. Okay. And yeah, that's fine. Let me just run the function Shinobi dot fight, and that function will work, but it'll only exist on Shinobi because we assigned it to Shinobi. That's Shinobi instance, not to the Ninja prototype. So ta-da! See, it worked. So there's a lot of different ways you can give an object methods. The question is, do you just want one version of the object to have a method, or whatnot? Now, I'm just thinking out loud. I'm thinking of an interesting way that we might be able to do sort of composition. You know, by adding like a special powers. So if I want to create like a bunch of ninjas, I want to be able to give them different types of powers, but I don't necessarily want I mean, I guess there's different ways of doing everything, but the way I'm thinking will work, but probably it'll be on the scope of this particular video. Again, the point was just to show you the different ways to declare methods. Okay, and the trade-offs. So again, the trade-offs are, if it's part of the object, it'll run faster but take up more memory. If it's part of the prototype, it'll take up less memory and run slower. And again, the actual real performance difference you'll probably notice with either way in most situations will be none. But if you find your software is running into like memory issues, then you may want to reformat how some of your objects work to let the prototype do more of the heavy lifting, because that way you only have the memory is only holding one instance of the function instead of holding an instance of the function for every instance of the object. So hopefully you guys found that interesting. My name is Alex Merced from alexmercedcoder.com.